Jupiter, the largest planet in our solar system, has a fascinating and diverse collection of moons, over 90 known ones as of now. The most significant moons of Jupiter are the 4 Galilean moons, which were first observed by Galileo Galilei in 1610. These 4 moons are among the largest in the solar system and are crucial to understanding Jupiter's system. I'll break down Jupiter's moons into categories for clarity. Galilean moons. These 4 moons are the most famous and largest moons of Jupiter, discovered by Galileo. Size. Diameter of 3,643.2 kilometers, the 3rd largest moon in the solar system. Composition. Mostly rocky with a thin sulfuric atmosphere. Surface features. Io is the most geologically active body in the solar system, with hundreds of active volcanoes, including massive lava flows. These eruptions are fueled by tidal heating caused by gravitational interactions with Jupiter and other moons. Orbit. 1.8 days. Io is in synchronous rotation, meaning one side always faces Jupiter. Europa. Size. Diameter of 3,121.6 kilometers. Composition. Primarily made of rock and water ice, with a subsurface ocean beneath its icy crust. Surface features. Europa's surface is covered with cracks and ridges due to tectonic activity, hinting at its internal ocean. It's considered one of the most likely places to search for life beyond Earth. Orbit. 3.5 days. Europa is tidally locked, with one hemisphere facing Jupiter. Ganymede. Size. Diameter of 5,268 kilometers, the largest moon in the solar system, even larger than Mercury. Composition. Ganymede is a mixture of rock and water ice. It's believed to have a liquid iron-nickel core, a magnetic field, and an icy surface with water beneath. Surface features. It has a mix of dark, older regions and brighter, younger areas, with ridges and grooves likely formed by tectonic forces. Orbit. 7.2 days. Like the other Galilean moons, it is tidally locked to Jupiter. Callisto. Size. Diameter of 4,821.4 kilometers. Composition. Mostly ice and rock, with a dense core of iron and nickel. Surface features. Callisto's surface is heavily cratered, which suggests it has been geologically inactive for billions of years. It may also have an ocean beneath its surface, although it's more uncertain than Europa's. Orbit. 16.7 days. It is also tidally locked, showing the same face to Jupiter at all times. Irregular moon. In addition to the Galilean moons, Jupiter has many smaller irregular moons. These moons have eccentric orbits and are often captured objects, likely asteroids or comets that were pulled in by Jupiter's gravity. Some notable irregular moons include Himalaya. Size. Diameter of 170 kilometers. Orbit. Himalaya orbits in a retrograde direction, opposite to Jupiter's rotation, and has a highly inclined orbit. Alara. Size. Diameter of 86 kilometers. Orbit. Alara has a prograde orbit, meaning it moves in the same direction as Jupiter's rotation. It is the 10th largest moon of Jupiter. Pasiphae. Size. Diameter of 60 kilometers. Orbit. Pasiphae is one of the more irregular moons, with a retrograde orbit that is highly inclined. Trojan moons. Jupiter also has a group of moons that share its orbit around the Sun, called Trojan moons. These moons reside at two stable points, 60 degrees ahead of and 60 degrees behind Jupiter in its orbit. These positions are known as Lagrange points. 2010 XW. Size. Around 4 kilometers in diameter. Orbit. Located at Jupiter's L4 Lagrange point. 2011 J1. Size. Approximately 6.5 kilometers in diameter. Orbit. This moon is located at the L5 Lagrange point. Discovery and naming. Most of Jupiter's moons were discovered in the 20th and 21st centuries through observations by telescopes and spacecraft. The first 4 moons, Galilean moons, were discovered in 1610, but many more have been discovered through spacecraft missions like Voyager 1 and 2, Parker Solar Probe, New Horizons, and most recently Juno, a NASA mission studying Jupiter itself. The moons of Jupiter are typically named after figures from Greek and Roman mythology, especially gods and characters associated with Zeus, Jupiter in Roman mythology. For example, Europa is named after a Phoenician princess loved by Zeus, while Ganymede is named after a Trojan prince. Interesting fact: tidal heating. Many of Jupiter's moons, particularly Io, Europa, and Ganymede, experience tidal heating due to gravitational interactions. This heating leads to geological activity, such as volcanic eruptions on Io and the potential for subsurface oceans on Europa. Potential for life. Europa's subsurface ocean, coupled with the possibility of hydrothermal vents on its ocean floor, makes it one of the most promising places to search for extraterrestrial life. Magnetic field. Ganymede is unique because it has a magnetic field, the only moon in the solar system known to do so. This is due to its liquid iron-nickel core. Missions and exploration. NASA's Juno mission, launched in 2011 and currently orbiting Jupiter, is providing detailed information about Jupiter itself, as well as its magnetic field and moons. Future missions like the Europa Clipper, set to launch in the 2020s, are focused on exploring Europa's ocean and potential for life. In summary, Jupiter's moons are a fascinating collection of objects, ranging from small, irregularly shaped bodies to massive, geologically active moons. These moons provide critical insights into the formation of the solar system and the conditions that could support life elsewhere in the universe.